Alright, I'm going to work out 5 of the problems from the homework assignment from 8.2. You were assigned 10 problems, 8 through 18 and 28 through 34 on page 470, all evens. And I'm going to work out half of them. I'm going to do number 10, 14, 18, number 30, and 34. So I'm going to go ahead and get started with number 10. Now, this problem set asks you to write your answer using exponents, so you don't have to fully simplify the problem, which should save you a little bit of time. So you have 3 over 2 all to the 4th power. This is a quotient of powers. So you have a quotient, fraction, 3 divided by 2, and it's all raised to the power of 4. Now you have to deal with the numerator and denominator separately. Treat them as separate bases. The 3 has a hidden exponent of 1 and 2 has a hidden exponent of 2, and then you treat them like powers of power problems. So you have an external exponent and an internal exponent, and you multiply them against each other. 1 times 4 is 4, 3 to the 4th, 1 times 4 is 4, 2 to the 4th. Now, while you could simplify this problem, the homework doesn't ask you to, just tells you to leave the problem in its exponential in form of exponents. So good to go for number 10. Next up, we're going to do number 14. Is pretty much the same type of problem, except they have it written down like this. So 1 over 9 to the 5th power times 9 to the 11th power. You can rewrite this problem just like this. And make it 9 over 11 divided by 9 over 9 to the 5th. So 9 to the 11th divided by 9 to the 5th. So now you have 2 bases and you're dividing them into 2 identical bases, and you're dividing them. In this case, you just subtract the exponents, which is 11 minus 5. So this is going to be 9 to the 6th. That was number 14. Let's take a look at 18. 18 is 4 to the 9th power times negative 1 over 4 to the 5th power. So this one we're going to leave alone for right now and concentrate on here. So look at this problem and look at this problem, very similar now that you're comparing these two. So you're going to treat the numerator and denominator separate. So the negative 1 is an exponent of 1, the 4 has an exponent of 1, and this is a power to the power problem if treated separate, the numerator and denominator. So you're just going to multiply the exponents of each numerator and denominator by the external one, or another way of thinking about it, you're going to distribute the external exponent to the exponents of negative 1 and 4, which are both 1. So you're going to get, so I'm going to rewrite this over here, 4 to the 9th, because that didn't change, times negative 1 to the 5th power and 4 to the 5th power. Now I'm going to rewrite it like this. 4 to the 9th power times negative 1 to the 5th power all over 4 to the 5th power. Now, can't really do much about the negative 1 because there is no other base that's negative 1. But the 4, I have a 4 up top, a 4 on the bottom, so I have 2 exponential forms for the same base. This I can work with. So if you have 2 exponential forms to the same base and they're being divided, you subtract the exponents, 9 minus 5, which is a 4 on the top. The negative 1 to the 5th just carries over, and there's nothing left on the bottom, and you're finished. So that was the first problem set. Now let's do a few problems from the second problem set. I'm going to do problems 30 and 34. So for these problems you have to simplify the expression, which means you have to fully simplify it. If you don't just leave it in exponential form if it can be simplified further. So let me show you what that means. Number 30, you have x squared over 3y cubed. So x squared over 3y cubed. Everything taken to the second power, so everything squared. Again, just like the problems here, just like this problem for example, you treat the numerator and the denominator separately and then you kind of combine them. Let's look at the numerator first. That's x squared to the second power. This is like power to the power problem. In this case you multiply the exponents, so 2 times 2, x to the fourth power. Down here in the denominator you have two separate bases, a 3 and a y. The 3 is to the first power, it's not written, it's hidden. So you have to distribute this 2 to both of them. 1 times 2 is 2, so you get 3 to the second power. 3 times 2 is 6, so you get y to the sixth power. Now, while it's done and it's in exponential form, you can further simplify this right here, the 3 to the second power, because 3 to the second power is 3 times 3, which is a 9. So you get x to the fourth power on the top, and then 9y to the sixth power. And now you're almost finished. The only thing you have to do is write down that y can't equal to a 0, because you can't have a 0 as a denominator, because you can't divide by 0. And now you're finished. For number 34, you have 3 over 8m to the fifth times m to the fourth power over n to the second power whole cubed. This is a bit of a complicated problem. It's a compound problem, so there's a few things going on at the same time. I'm going to treat them separate for right now. I'm going to deal with the right part first, and then I'll deal with the left part next. So dealing with the right part is pretty simple. You do numerator first, then denominator, and you multiply or distribute the external exponent to the internal exponents. So we'll rewrite this as the first part stays put, nothing happens, times 4 times 3, that's 12, so you get m to the 12th power. 2 times 3, that's 6, n to the 6th power. Now I'm going to rewrite it as one big giant fraction. On the top you have 3 times m squared. On the bottom you have 8 m to the fifth, n to the sixth. Alright, well, let's look at the bases. 3, 8, nothing in common. N, nothing in common. M and m, I have a pair of m's. So I have a pair of exponential forms that have the same base and they're being divided. And in this case, I'm going to kind of treat these two right here separately just for a second. So I have m to the 12th power divided by m to the 5th power. So I'm going to subtract the exponents, 12 minus 5. So I have again 3 times, now it's going to be 12 minus 5, which is 7, so m to the 7th. 8, there's no more m on the bottom, I still have the n. And that's it. And you have to write down that neither m or n can equal to a 0. So m and n cannot equal to a 0 because they are variables found in our denominators. But that's your final answer. Can't simplify it any further. 3 over 8, that doesn't simplify. M and n, different bases. Can't do anything with the exponents there. So that is it. That concludes the 5 problems that I worked out for this homework. The other 5, hopefully you can do on your own. If not, we will go over them in the class next time we meet. Thank you. Have a nice day.